Hi, my name is Colin Dagg. I'm a student at International Academy West in Huron Valley Schools, and I'm also part of the local robotics team, the Hot Robotics team. As a part of this year, I was challenged with using optimization tools from Altair to create a very light and strong support as a critical piece in the robot. So let's take a look. So if we come up here, I have the full SolidWorks assembly of the robot, and in it we have this intake that is attached to, if you look over here, the hopper. So if I go and erase this intake for right now so you can get a closer look, and we go underneath the hopper, we can see the supports here that are holding it up, and that are also going to be right next to this motor over here that will have an axle going through the support. So let's isolate that and look at it more closely. So these two supports here, the first thing you'll notice is that it's one big connected piece, and beyond that, there's also these two holes that run through them so that the axle can drive safely and be separated from them. So on this piece we had a few issues. While it worked fine, the main points were that first off, because there was an axle running through it, it had this weak point over here, which we fixed by adding this bump over there. And some issues with that though, that we wanted to solve by using Inspire, were first off make it a lot lighter because this piece started off very heavy. We wanted to take this bump out so it looked more smooth and moved more, kept more flow. And then also we wanted to keep this very, very rigid, despite having less weight, because that would keep the robot more stable. So, taking it into Inspire, the first thing that I did was made the design space a lot larger, while still keeping it away from the axle, so that Inspire had more to work with in this design space. And we also isolated the top and bottom from that so they could still stay and maintain contact with the rest of the robot. Going off of that, I added a 40-pound load from the top and then 7-pound shear loads in each direction so that I could withstand hits rather than just having a top load. So the first thing that I did was make a max stiffness design while keeping the mass relatively high. And while that was good, it had a couple of issues. It was still pretty heavy, and while it was sturdy, we wanted to go a lot lighter because we knew the robot could take less weight and this would still stay really sturdy with Inspire software. So if I erase this max stiffness and then come up to the minimum mass, this design really is what we ended up wanting to go with. It was a lot lighter, but still had really, really good stiffness, and also just looked super cool and organic and really had that Altair look to it, which was super cool. And we decided to go with this in the main robot assembly, and that was our final product. So the final step in the process is going to be looking back at this and making sure it still holds up using the analysis tools. So looking at the displacement, it's going to be displacing to a maximum of like 16 thousandths of an inch at the top, and at the bottom there's basically nothing, so that's going to be very, very sturdy. And looking at it through the factor of safety, it has a factor of safety of 6 at almost all the points on the piece except for down here where it is at 3. So I could basically stand on this piece and it would still stay really sturdy inside of the robot. So when making the actual part, we first prototyped it at home using a standard filament printer. So that's the kind of general stuff that you'll see at like a school or in your house, and it lays down lines of PLA or plastic to create the final product. So while it's good, it had some issues, such as that the layers of plastic create kind of a weak point, so if it's hit by a side load, then it can snap. So to fix that issue, going into our final revisions, we used an SLS printer that fuses together a powder of nylon and carbon, and that creates a lot more of a continuous and sturdy design, while still maintaining the structural rigidity and overall making a really good final print for the robot. So after we finished optimizing and lightweighting the left support, we moved over to the right one and did the same thing, and then put them both back into the main design for the robot. So these were both a lot more lightweight than the original, coming out at about 0.18 pounds, while the initial designs were about 0.7, so we got a lot of weight saving while still maintaining the rigidity and robustness of the robot. Doing this project has really shown me that despite being easy to use, Inspire is very powerful because it lets me do a lot of optimization work and then analysis work on my parts. And going into the future, I plan on using that a lot more in more complex designs in the robot, as well as just in my personal engineering projects, so I can really get better solutions and more effective products in the future.